Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of factoring trinomials. This is standard A.10E in the great state of Texas, and we are using item number 11 of the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we need to factor this expression, this x squared minus 17x minus 60. Now, if we wanted to, we just could FOIL out each of these four answer choices and find which one gets us the correct answer, but let's see if we could do it without that. Right? So, a few different ways to solve this. I kind of prefer the diamond method, though that's not the only way to do it. So what we're doing here is we are matching this up with standard form, right? So ax squared plus bx plus c. Because what we're wanting to do is we're wanting to label each of these terms, right? So this a would be right here, that coefficient in front of that x squared, and the leading coefficient is just not there. So we can say, all right, a equals 1, right? Because anytime you get an invisible coefficient, you can say it's just 1. My b is going to be negative 17. It's right there. And then my c is going to be negative 60. Now, how does that help me? Well, in this top section, what we want to do is we want to multiply a times c. So 1 times negative 60, negative 60. In the bottom section, we want to just write whatever the b is. Okay, so negative 16. What we're looking for is we're looking for two factors of negative 60 that multiply to negative 60, but add to negative 17. So since it is going to end up as a negative product, we know that one of the factors is going to be positive, one will be negative. So let's just deal with factors, and we're going to look for a combination that could get us to a negative 17. Right, so 1 and 60, it's not going to do much good. 2 and 30, I could make that a negative 28 if I made that a negative. That's as close as I can get, or if I made that 30 a negative, right? But look at this one, 3 and 20. Okay, so if I made that a positive 3, I made that a negative 20, that would give me my negative 17. I can keep going if I want to, 4 and 15, right, and 5 and 12, but we're not really going to see any other combinations. So that's really what we're looking for right here. What are the combinations? And we're just kind of playing with numbers in our mind. And it looks like if I have a positive 3 and a negative 20, we're going to be good. Now, what we do here is we write our ax over one of our factors, okay? So our a is going to be 1, so it's really just going to be x. But sometimes you might have an a value that's something else. You do that in case you need to simplify. So x over, we would say, a positive 3. And then the other factor, x over negative 20. Once again, you do it like this because sometimes if that a term is anything other than 1, you might be able to simplify. But now we're going to take each of these here and turn those into our two binomials, right? So the first part of the binomial is just going to be that numerator x, and then that's a positive 3. The denominator is that second part. So it doesn't end up as a fraction. Like I said, we just do it for possible simplification. The second part is going to be x, and I've got a minus 20, so minus 20. How do we know for sure? Let's FOIL this out just to double check, okay? So the first terms, x times x. But the outer terms are going to be x times negative 20. The inner terms, right, are going to be positive 3x. And then the last terms are going to be that positive 3 minus 20, so that's going to end up being x squared, and we need to get simplify that minus 20x plus 3x. It's also the same as if you wanted to think 3x minus 20x. Either way, it's going to get you a minus 17x. And then that plus 3 minus 20, right, that's what we were playing with that whole time. That ends up getting us our negative 60. So this FOILed out matches the original. That's how we double check. And so it does match the original, which means our answer here is going to be A.